Hey class! Today we will learn about the science behind aurora. If you are ever near the North or South Pole, you may be in for a very special treat. Frequently there are beautiful light shows in the sky. These lights are called auroras. If you're near the North Pole, it is called an aurora borealis or northern lights. If you're near the South Pole, it is called an aurora australis or the southern lights. This phenomenon is also called polar lights. The northern and the southern lights respectively occur when high-energy particles from the Sun collide with neutral atoms on Earth's atmosphere. The energy emitted from this crash produces a spectacle of light that mankind has marveled for centuries. What makes this happen? Even though auroras are best seen at night, they are actually caused by the Sun. The Sun sends us more than heat and light. It sends lots of other energy and small particles our way. The protective magnetic field around Earth shields us from most of the energy and particles, and we don't even notice them. The journey of these particles released by Sun is as simple as leaving the Sun and arriving on Earth. The protons and electrons creating the northern light depart from the Sun's corona. Corona is the outermost, hottest layer around Sun. Intense heat in corona causes the hydrogen and helium atoms to vibrate and shake off electrons and protons. These free electrons and protons move fast to be contained by Sun's gravity and group together as plasma and electrically charged gas. They travel away from the Sun as constant gale of plasma known as solar wind. However, the Earth prevents the solar wind from traveling straight into the planet by setting up a detour, the magnetosphere, which is formed by magnetic field around the Earth. Magnetosphere shields our planet by sending out the particles around the Earth. The opportunity to continue the journey down to the atmosphere comes when the magnetosphere is overwhelmed by a new wave of travelers. This event is called coronal mass ejection. This occurs when Sun gives off a massive ball of plasma and forms solar wind. So basically, the Sun burps out a huge bubble of electrified gas that can travel through space at high speeds. When solar winds collides with Earth, it overpowers the magnetosphere and creates a magnetic storm. When a solar storm comes toward the Earth, some of the energy and small particles can travel down the magnetic field lines at the North and South Poles into Earth's atmosphere. There, the particles interact with gases in our atmosphere, resulting in beautiful displays of light in the sky. After traveling for 93 million miles across the galaxy, the Sun's particles finally produce the dazzling light show with the help of some friends, which are oxygen and nitrogen atoms. The protons and electrons from Sun meet up the oxygen and nitrogen atoms on Earth's atmosphere. They sure are happy to see each other. The Sun's particles high-fives the atoms, giving their energy to oxygen and nitrogen atoms. So when the atoms in the atmosphere contact, they get excited and emit photons. Photons are small bursts of energy in the form of light. The colors that appear in the sky depend on the wavelength of the photons. Oxygen atoms are responsible for green and red color, whereas excited nitrogen atoms produce blue and deep red hues. The collection of these interactions is what creates the northern and southern lights. The polar lights are best seen on clear nights in regions close to magnetic north and south poles. Nighttime is ideal to observe this because aurora is much dimmer in sunlight and cannot be seen in daytime. Isn't it amazing? Let's see some polar lights here, till you get the chance to see this breathtaking view in real. Aurora also produce a noise, similar to a hissing, or crackling noise. which begins about 70 meters above the Earth's surface and is caused by charged particles in an inversion layer of the atmosphere formed during a cold night. The charged particles discharge when particles from the Sun hit the inversion layer, creating the noise. Few other interesting facts about polar lights are: two northern lights can never be the same. They are always of different patterns and colors. The further north you are, the better your chances of seeing the northern lights. The Arctic is the best spot for watching this phenomenon. In winter, you can see the lights from the Arctic even in the afternoon. Other planets also have them. Astronomers have spotted the lights on Jupiter, Saturn, Uranus, and Neptune. Isn't it amazing?